So in this video I'm going to talk about mathematical operations with significant figures. And we're doing this because it's very applicable to what you're going to do in experiments and labs, and also probably in math classes too. You'll collect some data and then you'll have some calculations to do with that data. And how do you report your answer? So in many cases it's going to be really obvious how you report it, but there are going to be also a lot of instances where you've got different levels of exactness. So for example, in this set of data that we have, the first number goes to 6 decimal places and then the last number goes to 2. So do you report to 2 or 6 or somewhere in the middle? And we have general guidelines about that sort of thing. So addition and subtraction are going to have one rule, and then multiplication and division are going to have another rule. You can think, the big idea of this is perhaps you can compare it to a chain or a length of chain. How strong that chain is depends on the weakest link. So if all the links are all the same, great, but if there's one link that's weaker, that dictates how strong the chain is. So the smallest number, the least exact number tells you how you need to record your data in both cases, but they are slightly different. So for addition and subtraction, what you're going to do is record your answer to the least number of decimal places from your data. So the answer that you write down can't be more exact than the least accurate measurement. And in this case we've got 2 decimal places is the least exact number. So we couldn't report our answer to this sum more than 2 decimal places. So what you'd actually do is, if you're adding all these numbers up, let's say that you've taken some measurements and you're working on a lab report, for example, you add them all up on your calculator and then you get your answer, and in this case it is 24.694633. I've got it written down so I didn't memorise it. But you've got to round this to 2 numbers after the decimal, or 2 decimal places now. So we'll go over some basic rounding rules in class, just as a quick reminder if you've forgotten. But to round this number to 2 decimal places, we look at the next number over, or the 3rd decimal place. If it's a 4, that means we keep this number the same. If it was 5 or higher, then we bump it up 1. So in this case, we're going to eliminate all these numbers, and our answer is going to be 24.69 grams. And the 2 decimal places matches the least exact number in our data. Slightly different, but similar sort of concept in addition, multiplication, division. We're going to use the least number of significant figures. So you're looking for, and you've got to apply that idea of significant figures and counting them. In this case it's pretty obvious because there's no zeros. So remember that anything that's not a zero is always significant. I'm not going to repeat the whole sets of rules for zeros, but you'll have them in your notes, so you can always go back and reference them. But the idea here is when we put these 2 numbers in our calculator and hit enter, we're going to get a long value, but what we're going to do is round it to the least number of significant figures. So the first step here is to count how many significant figures are in the least exact number. So you don't need to do every single one. You're only interested in the smallest number of significant figures. And in this case, we've got 1, 2, 3, 4, 5. So I'm going to put 5 significant figures underneath that, 1.3344. Because I know that when I write my final answer, when I rounded it, I'm going to go to that many significant figures, so I've got to do some rounding. So you do this on your calculator, and the result that you get is 30.8. So what we need to do is count 5 significant figures. So remember that because you've got this 0 in between 2 other numbers, it's significant. So we've got 1, 2, 3, 4, 5 significant figures. Colour. So this is where we're going to round this number to. And because this is a 4, we're going to keep this 5 the same. So our answer in 5 significant figures would be 30.855. And that's it. That's all there is to it. Hopefully that's not too crazy. I think the trickiest thing is remembering the two separate rules for the two different types of operations. And I think with practice that will become more familiar. So just to recap really quick, operations with significant figures, two separate groups. Addition, subtraction, you're going to round your answer to the least number of decimal places in your set of data. And in this case, the least number of decimal places was 2, so that's why we rounded down to 2 decimal places down here. Multiplication, division, you go to the least number of significant figures, and in that case, we had the least number was 5. I didn't even bother counting how many significant figures were in this number, because I know that I've got to go to the least number. So save yourself a step there. I wrote out my value, and then I looked at 5 significant figures, and then how do I round it? So you don't just chop off numbers, you actually do rounding. And in this case, we didn't need to change this 5 because that was a 4. And that's it.